Alright, this is group 40, and we're doing problem 8.28. Now as you can see here, this is all the given data. Here's your diagram, all your sorted variables that are given in the problem. You see here, I've added the arbitrary lengths h1 and h2. It's going to help us develop a manometer equation so that we can solve this problem. We're looking for h as our final solution. Now, the first thing I did is I set up a manometer because that's what I knew how to do. I didn't really know what this was asking for. So the first thing I did was do what I know, made a manometer. So from here we go from surface 1, which is right here, to surface 2. Quite simply, it's just P1 plus gamma H1 minus gamma M H plus gamma H2 equals P2. Now, we have a lot of variables that we don't know in here, but you just want to carry through with them, and hopefully they go away in the end, and this problem you'll see that they will. So whenever you don't know what you're doing, whenever you can't figure it out without variables, just keep adding variables, and they should cancel out if you're doing it correctly. So then I rearrange this to find that P1 minus P2, which I'm calling delta P in this equation, is equal to gamma MH minus gamma H1 minus gamma H2. Now, here's where the variables start to cancel out and you get left with the usable equation. So I said H1 equal to L minus H2 plus H, which you can see from here is true. So you go ahead and plug that back into the equation delta P up here, and you get delta P is equal to gamma MH minus gamma L minus H2 plus H minus gamma H2. You see that these cancel out, and then you rearrange and you find this equation here, which is that H is equal to delta P plus gamma L over gamma M minus gamma. And those are all things that you can figure out from this problem. So we're going to call it equation 1, and we'll need that to find our final answer at the end. And from there, we know you need delta P, which you can find using pipe flow equations. So first thing we do in pipe flow is we want to figure out the Reynolds number. And to do that, we need to figure out the velocity of the flow. And we're given the flow rate Q. So flow rate Q is equal to area times volume. Rearrange to find volume equals Q over area. Finding that volume equals 1.2732 meters per second. And you plug that into the Reynolds number equation here, which is velocity times diameter over kinematic viscosity. Then plug in the numbers here, get the answer of the Reynolds number being 115.745, which since this is below the critical value of the Reynolds number, it shows that the flow is in fact laminar. And with this knowledge, if you look in your textbook, you'll find that the volume flow rate for a fully developed pipe system when the flow is laminar is equal to Q equals pi diameter to the fourth times delta P plus gamma L over mu L. So rearrange that, you get delta P is equal to Q mu L pi over pi d to the fourth. And with these two equations, with this equation, which we'll call equation 2, you can plug that into equation 1 and get your final answer. Now, we don't have the values for mu or any of the gammas from the manometer equation, but we do have the specific gravities, which is enough to figure that out. So the specific gravity of something is equal to, I don't know if that's there, but, wait, no, that's right, yes. It's gamma over rho, the density of water times gravity. So rearrange that, you get that gamma is equal to the specific gravity times rho of water times gravity. Plug the equation, you find this specific gravity of the fluid is 8,534.7 newtons per meter cubed. Then you do the same thing to find the gamma of the manometer fluid, and you plug in the numbers there into the same equation, and you get that the gamma of the manometer fluid is 12,753 newtons per meter cubed. Then the last variable that we need to find here is mu. So mu, well, the kinetic viscosity is equal to mu over rho. So we rearrange that and we get that mu is equal to kinetic viscosity times the rho of water times the specific gravity to find the rho of the fluid. So plug in the numbers here and you find out that mu is equal to 0.1914 newtons times second per meter squared. Now we go all the way back to equation 2 here and plug in all the numbers we just got here. You get that delta P is equal to Q mu L over pi d to the fourth minus gamma L. Just plug in the numbers You find out that the change in pressure between surfaces 1 and 2 is 43,844 pascals or 43.84 kilopascals. Then you go all the way back to equation 1, which is that H is equal to delta P plus gamma L over gamma M minus gamma. Again, you simply plug in the numbers that we found preceding this point, and you finally figure out that H is equal to 18.486 meters.